today is about logarithms. How is it related to exponential equation? So if you will see this setup here, so we have this log, and you have this b, which is your base, and then you have a is equal to x. And you read this as the log base b of a is equal to x. Okay, again, that's how you read it. Now we have two forms. Logarithmic form, we are going to change it to its exponential form. So how are we going to do that? So in the exponential form, it will be like this. You have to write your base. And then this will be the exponent, so you have x is equal to a. That's it. Okay. Again, this is the log form. Convert it to its exponential form, it will be like this. So you have b raised to x is equal to a. Okay, so let's have an application. So write this one, so we're going to do this. Write each equation in exponential form. So you read this as the log of 3, your base 3 of 9 is equal to 2. You are going to change it to its exponential form. Your base is 3. Exponent is 2 is equal to 9. Okay? Did you get it? Any question? Okay. How about this one? What is the exponential form of this? The log of your base 6 of 216 is equal to 3. Change it to its exponential form. Just it.
6 to the third equals to
Okay, so it will be 6 to the third power is equal to 260. Okay? How about this one, Noah?
7. Do we put to the 0?
Raised to 0, yes.
Equals 1.
Okay, if you have noticed, class, if you want to double check, 3 squared is equal to 9. We are equal. And in here, any expression raised to 0 is always equal to 1. Okay? How about number 4?
2 to the fourth equals
Okay,
to
2 to the fourth power is equal to 16. That's it. Okay? That's it. Jesse? Okay, let's have number 5. Noah, what was your answer for number 5?
4 to the negative
4
second.
raised to negative 2 is equal to
160.
1 over 60. Next, Jesse?
For number 6,
Yes, please.
9 to 3.
3 over 2.
Yeah, 3 over 2 equals 27.
That's it. Okay. For the next part, we are required to change it to its logarithmic form. Okay? Again, this is your base, exponent, and then the value of your a. So we can write it as the log of your base 14, okay, of 196 is equal to 2. Okay? So this is the exponent. Again, the log of your base 14 of 2, this is the of 196 is equal to 2. Okay. Noah, can you please try number 8? What is your answer for number 8?
Log the third,
Okay, the base 3.
and then 81
Okay.
equals 4.
Equals 4. That's it. Okay, very easy. Okay. Let's have number 11. Jesse.
11.
Yes.
Log 2.
Okay.
Log base 2.
Okay.
1 8
1 over 8.
equals negative.
That's it. Okay. Noah, number 12, please.
Log 8,
Okay, base 8. Okay.
16
Okay, 16.
equals 4 over 3.
Over. That's it. Okay. Can you please do number 9 and 10 in your paper? Okay, Jesse?
Log
let's proceed on the second page. So we're going to deal with common logarithms, okay? So before we proceed with this, if I have x, just x, what is the constant? What is the coefficient? I'm sorry.
One.
It's 1. What is the exponent?
0.
0 or 1?
No, 1.
1. No need for you to write it, okay? Just like in the common logarithm. If your base is 10, no need for you to write it, okay? You can just write it as log of x. If your base is 10, okay? So let's have, okay, let us now evaluate this one. We are going to use this later because there are some examples, they have no given base. So let's have number 13. You are going to evaluate. This is, application also of the exponential equation, okay? So first, you have to set it up. There is a missing part here, okay? What do you think is the missing part? You have your base. What is this? This is your A. What is missing? X. So your X is missing. Okay. So again, change it first to its exponential form. So you have 7 raised to x is equal to 49. Okay. Going back to the previous lesson, how can we make our base the same? How can you relate 49 with 7? What?
7 to the second.
7 to the second power, okay? So it will be like this. 7 raised to x is equal to 7 squared. Okay? Again, we got this from 49. 7 times 7 is 49. Since we have the same base, can we cancel, Jesse? Okay. So what is now the value of your x?
2.
2. That's it. Okay? So the value of your x is 2. Let's have number 14. Let's set it up into an exponential form. So you have 3 raised to x is equal to 27. So what are we going to do next?
You do 3 to the third
Yes.
power.
So change this to 3 to the third, and then you have 3 raised to x. What's the value of your x?
3.
Okay, for number 15, do we have a given base?
No.
No. So we can apply the common logarithm. What do you think is our base? Even if it's
10.
not written, it's 10. So it's going to be 10, okay, raised to x is equal to 100. So what's our x?
2.
2. Okay. So let me show you this one. This will be 10 to the second power. So you have 10. Cancel, cancel. The value of your x is 2. Okay. Can you please do the rest? 16, 18, 17. Okay, let us now do the rest. Okay. So let's have number 16. What is the setup for this, Noah?
12x equals 1
12 raised
To the x.
x is equal to 1. So from this example, can we cancel 12 and 1?
No.
So we don't have a common base. So you have to make a way on how to make them, how for you to have a common base. So remember the example I gave you, any term raised to 0 is equal to 1. Okay? If we're going to put this is equal to 1. If we are going to put 12 raised to 0, what is the equivalent of this? It is 1. Okay? So we have 12 raised to x. Do we have a common base now?
Yeah.
Yes. So the value of your x will be 0. Okay? Number 17, what's your answer?
X
Okay, x is equal to 6. Okay. Number 18, x is equal to 5. Okay. Next. Jesse, can you please set it up?
9
Raised to x.
equals 1 over 8.
Okay, 81. Okay, if it's like this, we have to make a way on how to make them the same base, okay? What are the factors of 81 to get, to have a base of, to have, use 9 as your
9
base?
squared.
2. So this is going to be, okay, I'm going to show it to you, okay? 9 raised to x is equal to 1 over 9 squared, right? Yeah? But, okay, they're not yet the same. So what we're going to do, we put it up, just the same as the previous lesson. If you put it up, what's going to happen with the exponent? It will turn out to be a negative. So you have 9 raised to x is equal to 9 raised to negative 2. Noah? Are we okay? Okay. So can we cancel our base now?
Yeah.
Okay. So what's the value of your x?
Negative.
Yep. So x is equal to negative 2. That's it. Okay. Jesse, what's the setup for this? 64 raised to x.
Equals to 4.
Okay. Base. How many times you need to multiply 4 to itself to get 64? How many times? Because we can cancel it like this.
3.
3. Okay, so this is going to be 4 to the third power is equal to, okay, it is 4 to the third power, but you have an x next to it. So you combine it with this, okay? Write it like this, is equal to 4. What is the exponent of this? It's 1, right? 1. Do we have the same base?
Yes.
Okay, cancel. So you have 3x is equal to 1. How will you solve for your x?
Divide by 3.
Yes. Divide both sides by 3. The value of your x is 1 over 3. That's it. Okay, let us now proceed with the next topic, which is change of base formula. Okay? So in here, you are going to use a formula which is the log of your A over log of your B. This is another way of solving for your x. But sometimes, the answer is a decimal, So let's have this one. The value of your A. Don't interchange, don't mix this one. This is your B and this is your A. Set it up. So it is going to be the log of your A. What is your A? So you have 64 over log of your 60. Okay, put it in your calculator. You can use the fraction form. Press alpha, y, enter. And then you give me the first, maybe 2 decimal places. So the value of this is what? Come on. Log.
1.5.
The answer is
1.5.
That's it. Okay.
Hey.
Got it? Okay, so let's have number 22. Do the same thing. Use the formula, okay? So the value of your A, so you have log of 32 over log of 8. Answer please. Answer.
1.66.
It's continuous, right? So it's a repeated decimal, so we can also write it like this. Okay. Number 23, 24. Okay, let's do, can you please do this one? Number 26. Because I know you can do number 23, 24, and 25. Let's have number 26, please. So you set it up. So you have log of 1 over 36 all over log of 6. The fraction form in your calculator, you press alpha, y, enter, okay?